In this video, we'll see the implementation of quick sort in Python. This function sorts the elements of this list A using quick sort technique. And here we are testing this function for these different lists. Now let's see how this function quick sort works. Inside this function, we have called this recursive function sort that will sort our list. This is the recursive function sort. This low and up denote the start and end index of the sublist that has to be sorted. Initially, we have to sort the whole list. So we are sending 0 and last index of list as the values of low and up. We know that the terminating condition for recursion is when the sublist formed contains 0 or 1 element. The sublist will contain 1 element when low is equal to up, and the sublist will have no element if low is greater than up. So we have taken low is greater than or equal to up as the terminating condition for recursion. This function partition places the pivot at its proper position and returns the position of pivot, which we'll store in this variable p. Now left sublist and right sublists are sorted using this function recursively. Left sublist is from index low to index p minus 1 and right sublist is from index p plus 1 to index up. Now let's see how this function partition works. The first element A low is taken as the pivot. We have taken two variables I and j. I is initialized with low plus 1 and j is initialized with up. So I is moved from left to right in the list and j moves from right to left. Now in this loop, we'll find the proper place for pivot. It executes till I is less than or equal to j. In this inner while loop, I moves from left to right till ai is less than pivot. And in this while loop, j moves from right to left till aj is greater than pivot. In this loop, we have placed this condition I is less than up to stop I from crossing the right boundary. And this j will never cross the left boundary because pivot is there at the leftmost position to stop it. Now after both I and j stop moving, if I is less than j, then ai and aj will be swapped, I will be incremented and j will be decremented. And if I is not less than j, that means we have found the proper place for pivot, and that proper place is at index j. So element at jth position is placed at index low and pivot is placed at jth position. And this value of j is returned because it is the position of the pivot. Now let's understand the working of this function partition with the help of some examples. Here low is 0 and up is 11 and pivot is 50. I is initialized with low plus 1, so I is 1, and j is initialized with up, so j is 11. Now first we'll check whether we have to move I or not. ai is less than pivot, so we'll move I. Again, this ai is less than pivot, so we'll move I. Now this ai is greater than pivot, so we'll stop I here only and we'll go to j. Now aj is greater than pivot, so we'll move j. Again, this aj is greater than pivot, so we'll move j. Now this aj is less than pivot. 10 is less than 50, so we'll stop j here only. Now both I and j have stopped and value of I is less than j. So ai and aj will be swapped and I will be incremented and j will be decremented. Now again we'll check I. ai is greater than pivot, so we'll stop I. Now we'll go to j. aj is greater than pivot, so we'll move j. Again this aj is greater than pivot, so we'll move j. Now aj is less than pivot, so we'll stop j. Now both I and j have stopped and the value of I is less than j, so ai and aj will be swapped and I will be incremented and j will be decremented. Now we'll check whether we have to move I or not. ai is greater than pivot, so I will not be moved. We'll go to j. AJ is greater than pivot, so J is moved to the left. Now AJ is less than pivot, so J is stopped. Now both I and J are stopped, but I is not less than J. That means we have found the proper place for pivot, and that place is J is equal to 4. So this element is placed here and pivot is placed here. Now this pivot has come at its proper position. Let's take another example. Here low is 2 and up is 4, pivot is 30. I is initialized with low plus 1, so I is 3. J is initialized with up, so J is 4. So first we'll look at I. AI is less than pivot, so I is moved. Now again AI is less than pivot, but now we'll not move I because I is equal to up, and the condition I is less than up will fail. So we'll stop I. Now let's look at J. AJ is less than pivot, so J is not moved. Now both I and J have stopped and I is not less than J. That means we have found the proper place for pivot, which is J is equal to 4. So this element is placed here and pivot is placed here. Now pivot is placed at its proper position. Now let's take another example. Now in this example, low is 5 and up is 6. Pivot is 15. I is initialized with low plus 1, so I is 6. J is initialized with up, so J is also 6. Now we look at I. AI is greater than pivot, so I is not moved. Now AJ is greater than pivot, so J is moved. Now AJ is equal to pivot, so J is stopped. Now both I and J have stopped and I is not less than J. So we have found the proper place for pivot, which is given by J, and it is 5. So now pivot at its proper position. Now let's run our program and see the output. These are the lists that have to be sorted. Now let's run this program. So we can see that the lists have become sorted.